Let me tell you a bit more about our updated curriculum for the incoming batch.
This is an overview of our revamped curriculums for both our computer engineering and computer science programs. Let me go through each of the modules shown in the diagram. The first component shown on the top left corners of these slides are courses that all NTU students need to take in order to fulfill the new NTU interdisciplinary and collaborative core requirement. These interdisciplinary and collaborative core requirements embodies the NTU educational philosophy that undergraduates should be trained not just in narrow technical or professional fields, but also embrace interdisciplinarity through a collaborative learning environment that will be of beneficial to a broad range of occupations upon graduations. It covers courses in key transferable skill areas such as digital literacy, communications and inquiry mindset, ethics and civics in a multicultural world, career and entrepreneurial developments that forms the core competencies of a well-rounded graduate. Under this initiative, internship will also be compulsory for all undergraduate programs in NTU. The other component shown on the right is the broadening and deepening electives. These not only provide a wide selection of free electives and enrichment options to cater for individual interests, it will also allow students to take out more challenging and advanced topics within the chosen discipline. The next component contains two fundamental courses that students in the College of Engineering are required to take. These courses are Engineer in Society and Physics for Computing, which are particularly beneficial for graduates from our computing programs, as computings are now used extensively in various engineering fields. The rest are courses that belongs to the course and major of our computing programs. First are courses that are of fundamental importance in computing programs. The first group consists of the various mathematical courses that form the foundations for computing. The next group contains courses that focus in developing the skills of programming and algorithm design, which are directly related to the application of computing. Notice that all the courses mentioned so far are common for both the computer engineering and computer science students. Next are courses that will form the foundation of the two respective programs. For the computer engineering programs, the student will take courses such as logic and digital system design, microprocessor programming, operating system, software engineering, as well as computer organization, computer architecture, and computer network. Similarly, for the computer science programs, students will study foundation courses such as software engineering, database, operating system, as well as logic design, computer architecture, and computer networks that are also taken by the computer engineering students. All these courses together will form the fundamental requirements in the study of our computer engineering and computer science program, and should be taken and completed during year 1 and year 2 of the 4 years programs. Once the students have acquired the necessary fundamental core knowledge, they can then choose to study courses that are considered as the major and also specialize in one particular area of interest if required. Some example of the majors for the computer engineering programs are courses such as Embedded Operating System, Advanced Computer Architecture, and Signal and System. Example of computer science major are Advanced Software Engineering, Computer Security, Artificial Intelligence, and Data Mining. Students can also choose to specialize in certain areas such as cybersecurity, artificial intelligence, data science, Internet of Things, and any new up-and-coming area in the near future. The majors and specialization courses should be taken during the Year 3 and Year 4 of the program. In addition to doing the lab exercises in the various courses, students are also required to practice and apply the theories that are taught in the various courses in the forms of projects, such as the Multidisciplinary Groups Project, the MDP, and the Final Year Project, the FYP, to pick out problem-solving skills and learn how to work in a team. Another important module in our computing program is the Professional Internships, which is of 1 semester, 6-month duration. During the internships, a student is attached to a company whereby they can acquire work experience before graduation. These internships can be done with a local company or with overseas company and can be done in Year 3 or Year 4 of the studies. The curriculum of the double degree programs follows closely to the single degree computer engineering or computer science program, but with additional courses required to fulfill the requirements of the business degree programs, specifically the business analytics specialization of Nanyang Business School business program. As shown here, students in the double degree programs are also required to take the interdisciplinary and collaborative core, the broadening and deepening elective, the engineering and science fundamental courses, as well as the computing fundamental courses, the computing majors and specialization courses, and doing the MDP and FYP projects. In addition, they will need to take courses that belong to the course of the business study, such as financial accounting, financial management, marketing, strategic management, etc. They will also take courses that are major in the field of business analytics, as well as elective courses that integrate the area of business analytics and computing. Students in double degree will also do an internship, which is of 3-month duration and is known as professional attachment.
As you know, we also offer a dedicated curriculum for our data science and AI program. Let me tell you a bit about that program.
The Data Science and Artificial Intelligence program is a 4-year Bachelor of Science program jointly offered by School of Computer Science and Engineering and School of Physical and Mathematical Science. During the Year 1 of the study, students mainly take fundamental courses in area of mathematics such as calculus, linear algebra, and discrete maths, as well as some introductory courses in computing and data science. In year 2, the student will take 2 probability and statistics courses, which form the basis of data science. The student will also take courses that forms the fundamental core of computer science. For example, algorithm, software engineering, database, and object-oriented design and programming. In semester of year 3, students will take some of the computing major courses, such as artificial intelligence and data analytics. During the second semester of year 3, students will be expected to do a 6-month internship with company to acquire work experience and to learn how the theory that they learn in the studies are applied in real world. During the final year, students will take more in-depth courses that are mainly related to the various techniques used in data science and artificial intelligence applications. These courses are listed under the major prescribed electives as shown here. In addition, the student can also take this program in the form of the work-study degree program. Under the work-study degree program, students will be doing multiple internships during the 4 years of study. The internships will be taken as 3 months duration professional attachment with selected company during the special semester terms of year 2 and year 3. Students will then do a 6-month professional internship with the company before graduating from the program. In addition, the student will be doing an industry-sponsored final year project, which is a project proposed by the particular company that the student is attached to under this work-study degree program arrangement.
Our curriculum is always been broad-based and driven by industry demand. Come and join us to discover your passion and to realize your potential.